Now that we have gone over some angle proofs, I wanted to do a couple segment proofs for you so you can kind of see how those work as well. So just like the angle proofs, you're going to look at your givens. We'll take it piece by piece. So the first given here says that LM is congruent to PN. So I need to mark this on my diagram. So LM is this segment here. PN is this segment here. So I'm going to put my tick marks on that little bracket thing I drew rather than right on the line segment, because then I know I'm talking about the whole thing. And then we got to get that in our proof. So LM, these really should all have segment markings, congruent to PN. That was given to us. All right, then if I keep going, I have another given here. That is XM congruent to XN. So if I look at that, XM is this piece right here, and XN is this piece right here only. Okay, so that can go right on the segment. And if that's harder for you to see, let me highlight it. Just this part and just this part. Remember that we cannot use one tick mark for this. We have to use a different number because we already used one. So we can use two tick marks to show a different congruence. Okay, so that says XM is congruent to XN. That was given to us. Okay, now if we look at our proof statement, I know we're not there yet, but let's go ahead and look at it. That says LX is congruent to PX. So eventually what we're trying to show is this piece and this piece congruent. So we're starting with the entire segment and one piece of it. So what that tells me is that I need to do some segment addition here. So looking at this, I know that LX plus XM, that's going to give me LM. Okay, that's segment addition. You're adding the two smaller pieces together to equal the larger segment. So that is your segment addition postulate. I'm going to go ahead and do the same thing for the other segment there. We know that PX plus XN equals that entire segment of PN. And again, that is segment addition postulate. Okay, now we are trying to get just LX and just PX. So eventually we want to get just these guys. So what I'm going to do is I'm going to do some substitution. So we know that LM and PN are congruent from statement 1. So I'm going to plug them in for each other. So in statement 5, I'm going to go ahead and say, okay, LX plus XM equals PX plus XN. And again, what I'm doing, because these guys are here and these guys are here, we can substitute all that in. So since we're doing a couple substitutions, this is your transitive property of equality. And then I'm going to do one more substitution. Scroll down here a little bit. Okay, so one more substitution. So I also know that XM and XN are congruent from statement 2. So I'm going to plug in, if it'll let me fit this in here, PX plus XM. So I'm just substituting XM in for XN. That was just one substitution. So that's your substitution property of equality. Okay, now looking at this, we can see that we have XM on both sides here. So I'm going to subtract and get LX equal to PX. And that's because if I subtract XM from both sides, it's going to cancel out on both sides. And then because I know these guys are equal, I can go ahead and say segment LX is congruent to segment PX. And that's just definition of congruent. Remember, congruent means that they are equal, they have the same length. So that matches our proof and we are done. If we look back up here, that's what we were trying to prove, LX congruent to PX. We have it right there. So we are done. So this is another example of a segment proof. So again, we're just going to go in order of the givens. First thing you're given is that AB is congruent to DE. So again, I'm going to mark that up here and I'm going to put it right in my proof. The second part of this given says that B is the midpoint of AC. So what that tells me is B is the exact middle which means either side of it has to be the same. Well, this guy already has 1 tick mark, so I'm going to give this 1 tick mark. And when we put this into our proof, it has to be exactly like it's given. So B is the midpoint. I'm going to go ahead and abbreviate that again, of AC, and that was our given. Now, we have that vocabulary, so anytime there's a vocab word in your given, you go ahead and define it. So that's definition of midpoint. Okay, so what that told us was AB was congruent to BC. The next part of my given says that E is the midpoint of DF. So looking at our diagram here, that means E has to be the exact middle. So DE and EF need to be the same. Well, this already has a tick mark, a single tick mark. So I'm going to put a single tick mark on EF. And again, I'm going to get this stuff into the proof. So E is the midpoint of DF. That was given information. And then I went ahead and I defined that vocab word. So midpoint means it is the exact middle, which tells us that segment DE has to be congruent to segment EF. So now we're trying to get BC congruent to EF. That's our final goal, looking at our proof statement. So if you look at what we have already here in the proof, BC is in statement 3, and that is congruent to AB. Well, if I keep looking, I have AB here congruent to DE, and DE in statement 5 congruent to EF. So if I eliminate all that repeated information, I'm going to be left with BC congruent to EF. And anytime you are combining multiple things like that, eliminating repeated information, that is your transitive property of equality. So that matches our proof statement, so this one is done. All right, so this last proof, looking at our given, QT is congruent to RT. So I'm going to mark that up right here and get that into my proof. And that reason is given. The second part of our given is that TS is congruent to TP. So I'm going to mark that TS and TP. Okay, so TS is congruent to TP. So that is given. Now looking at our proof statement, we're eventually going to try to get QS congruent to RP. So if we look at that, QS combines the two that you're already given, and RP combines the two that you're already given. So we're going to go ahead and do some segment addition. So QT plus TS equals QS. We're going to do the same thing for the other side. So TP plus RT equals RP. All right, so both of these reasons are segment addition postulates, because you're adding the two smaller pieces together to get the whole thing. All right, so once we do that, we need to look at what we have already in our proof and figure out what types of substitutions can be made. Remember, our ultimate goal is to get just QS congruent to RP. So looking on the left-hand side of those equations, let's see what types of substitutions we can make. So statement 1 tells us QT is congruent to RT. So I'm going to plug in RT right here. I'm going to have RT plus, now looking elsewhere, here we have TS congruent to TP. So I'm also going to make a substitution here to substitute in TP for TS. All right, now what allowed me to do that was the substitution property of equality, because all I did was replace equivalent values. Now if you look at 5 and 4 together, here we have RT plus TP and TP plus RT. So essentially this is the same exact thing. The order's just flipped. And remember, addition is commutative, so it doesn't matter what order the addition takes place in. So because this is exactly the same as this, I can make one last substitution, and I can say that QS equals RP. So again, it's kind of like you're eliminating that repeated information. So you could really do substitution or transitive here. I'm going to go with transitive. And then once you have segments equal to each other, that means they're congruent by definition. So we can go ahead and say QS is congruent to RP. And again, that's just definition of congruent. Anytime that you are taking an equal sign and replacing it with a congruent sign, or vice versa, your reason is definition of congruent. Now this statement here matches your proof statement, so you are done with your proof.